Howdy everybody, welcome to the second day of GrafanaCon. I'm Alex Martin, Director of Professional Services here at Grafana Labs. We're going to start off with a quick run through of the most exciting features that will be making their debut in Grafana 8. Once you make the upgrade to version 8, you're going to immediately notice the first update. We've given an uplift to the existing themes. The login is already showing a more spacious and streamlined design. Not only have some of the colors moved around, but our design team has also focused on making it much easier to read and navigate throughout the app. I've got a couple of example dashboards here, and they're all monitoring the health of my Grafana Enterprise Metrics cluster. If we jump into this example folder and edit this top panel, you'll see a lot of this work put into the panel editor. Instead of the visualization picker taking up precious screen real estate, we've condensed it into a drop-down picker. We've also reorganized a lot of settings to be clearer and easier to manipulate. I know I've burned through more than enough time trying to figure out where some specific settings are. So the Grafana open source software team has gone and put in an option search to make that much easier. So say I've decided that the data points are making this graph way too busy, I can just search for points and boom, I can turn them off. Additionally, I want to highlight the new and improved metrics picker for Prometheus. Instead of just a long list of metrics to scroll through, you can now more easily search for metrics you want. And you can also search the labels and label values to help generate that next query. While we're here, let's talk about this brand new panel. So this might look a little bit like the old graph panel, but it's actually the new time series panel. We've taken the staple visualization that you know and love and replaced it with a panel that is completely focused on performance. You'll be able to cram all the samples from all the series without Chrome locking up your computer, unless you're still rocking a Pentium 2 or something crazy like that. We also have made it much more consistent with the new panels, meaning you can take full advantage of things like min, maxes, and the override system. It's also much more customizable than the old graph panel. So for example, let's take a look at this Grafana Enterprise Metrics read latency graph. Let's say I want to smoothen out the line in between data points. I can search for interpolation and choose a rounded interpolation. Not exactly super dramatic here, but for bigger data sets, you might be able to see more of a change. More importantly, how about these empty spaces in between samples? In this scenario, there are valid breaks in data where I haven't been requesting metrics on my gem cluster, so there is no data there because there are no requests. But what if I do want to connect the gaps? With the old graph panel, you kind of had to let the panel decide. But here in the new time series panel, you and I get to decide that. So if I search for null in the option search, I can now decide if I always want to connect the gaps. Or I can set a threshold. So if I put 5 minutes as the threshold here, it will only connect points within a 5-minute time span. I can also do a soft min-max. This is useful if you want to maintain some kind of minimum values range for your graph. So this graph actually has a threshold marker of 500 milliseconds, but you can't see it because the values aren't high enough. So I can add a soft max threshold of 600 milliseconds to clearly show this. But what happens if I make it something super low, like 10 milliseconds? What happens? As you can see, it's called a soft max because if the data in the graph breaks that threshold, the graph will ignore the soft max to show all the data. This is exactly true for soft min as well. The next thing I want to hone in on is the state timeline. This is the new kid on the block that replaces the popular discrete community panel. In this example, I've taken the exact same data on the read and write latency of my gem cluster, but instead of graphing it, I'm showing the discrete states. This gives a much clearer idea of how my individual components are doing in a certain time frame. So you can see that according to this visualization, it's probably time for me to invest in either beefing up my gateway or adding a second replica to share some work. As you can probably guess, this is a really convenient way of replicating something like a typical status page would show you. If you're using Grafana for industrial use cases, this panel can also help you understand the load on different parts of the supply chain. And as you can imagine, you'll be able to edit the panel and decide if you want to show the values for each state, or if you want to merge similar blocks of states, or even pick from some color schemes if you want to deviate from traditional green, yellow, red signals. Finally, we have two more panels I want to highlight. One of them raises the bar, and then the other one, I don't want to get too political here, but we do have a blog post titled Friends Don't Let Friends Abuse Pie Charts. So take that as you will. But yes, first off, we have the pie chart. It's got a very nice mouse over animation, and you'll have access to all the standard options and overrides. You can even change it into a donut. And right next to it, we have the highly anticipated bar chart. I'm sure analysts and executives all around the world are jumping for joy with this one. You'll be able to choose what you'd like to have, a vertical or horizontal display mode. And additionally, the bar chart is the first panel to be able to show non-time series data. So that means if you want to pull in some tabular CSV data, you'll be able to start incorporating it into your Grafana dashboards as well. The final update I want to talk about is library panels. So say I want to make another dashboard, but only focus on the right health of the gem cluster. But this overview dashboard already has a panel that I want to include in both. So what do you do? And before Grafana 8, you could copy and paste the panel, but if you found an error in a query, or if you wanted to adjust the thresholds or colors or pretty much anything else for both panels, you had to go in and actually copy and paste or replace, or if you're doing it with the Grafana API or using version control, you have to go and update the JSON for the whole dashboard. But now you can actually save this panel as a library panel and have them both linked. So I've already taken this panel and saved it as a library panel, as you can see with this nifty little icon that's on the title now. But if I were to do this from scratch, I would just hit the Save Library Panel button in the top right of the edit screen. So let's go to our brand new and empty right health dashboard. So to add this link to library panel, I would just hit the Add Panel button, and then you can see you can now pick Add a Panel from the panel library. I can now pick my right latency panel from here and toss it right into this dashboard. Now, what happens if I go in and edit this panel? So let's say I decide I want to get a little crazy and use the blue, yellow, red color theme for whatever reason. I can now select this and hit Save on the library panel. It's going to warn me that this would update the panel on two different dashboards, which is exactly what I want. So I hit Update All. I can go back to the overall cluster health dashboard, and then you can see that the panel has been updated here as well. So thank y'all. That wraps up my portion of the Grafana 8 OSS updates. There's still so many things in this major version to cover, and I hope you enjoy them all. I'm now going to turn things over to my colleague Tanya, who's going to tell you a little bit about some of our new enterprise features.
Thanks, Alex. Hello, my name is Tanya, and I'm a software engineer on the Grafana Enterprise team. I'm going to talk about what our team has been up to recently. I will be covering improvements in reporting, plus I'm going to demo our brand new query caching feature. My colleague Vardan will take it from there. He will demo another long-awaited feature, fine-grained access control. We ran a few user studies to decide how to move reporting forward based on your feedback. Many users asked for template variables and repeating panels in reports. Now we are adding them to Grafana 8, so if you requested it, we have got you covered now. From now on, apart from generating reports in PDFs, you can export table panels into CSV files. But now let's see how report configuration looks in Grafana 8. So I have this dashboard that shows all kinds of charts and tables for a few GitLab projects, and it uses the project as a template variable. It has repeating panels as well as repeating rows. And my manager is interested in getting a report for only one of my projects. So I created this status report for them. Previously, to send reports for a subset of projects, I had to create a separate dashboard for those projects and then create a report based on that dashboard. In Grafana 8, we have streamlined this quite a bit. Now you can choose only projects you need and get report with those projects. Here I selected GitLab because this is the project my manager is interested in. So I also added a link back to the dashboard in report email in case my manager wants to go explore data in Grafana itself. And I selected exporting table panels to CSV because many users find them useful, especially if they got used to do their data wrangling in Excel. Now let's look at the report I sent to my manager. Before, my manager would receive a fixed PDF report along with the data for all my other projects. Basically, they used to get a whole bunch of data they didn't really care about. Let's see what has changed. Now they see information for just that a single project they need. They can open up a CSV file with the opened issues and look at all the details. And they can link back right to Grafana for more up-to-date information. That's very nifty, right? But I will stop my demonstration here and get back to slides. We keep on working on reporting, so stay tuned for even more improvements. Another cool feature I'd like to showcase is query caching. Query caching eliminates sending duplicate queries to the data source. This makes dashboards load up faster and you are less likely to reach the API rate limits. It's extremely useful for high traffic data sources, especially if there has been an incident and many people look at the same dashboard all at the same time. Right now, query caching is supported by most backend data sources, including all Grafana Enterprise plugins. Let's see how it makes subsequent refreshes of my dashboard run faster. So here is the dashboard that is built on two identical data sources. I will enable query caching for one of them. That's going to be the one on the left. Let's see how it compares with the data source on the right. Query caching needs to be enabled in Grafana configuration file and then switched per data source. So in order to enable it for my data source, I go to its settings, then to cache tab and hit enable. You can either stick with the default cache time to leave or specify a custom value like I do here. But let's go back to our dashboard. So I need to wait for the first time charts get loaded. And then I refresh the page to see if query results for the panels on the left have been cached. And yes, indeed, the left side loads up faster, first of all, as you can see. And note that there is an icon that indicates that the left panel uses cache data. Right, so that's pretty much it on query caching from me. But if you're curious to learn more about it, join Kevin Meinhardt at his lightning talk on query caching. Kevin is a creator of this feature and he will go into more details on it. I really hope you find these features useful. Make sure you head to the Grafana Enterprise section at grafana.com for more great stuff. On the final note, a huge shout out to Luca, my 4-year-old nephew. I wouldn't have survived this past year without him. I basically lived off his playful, goofy vibes. And with that, off to Vardan to talk about fine-grained access control.
Hi everyone, and thank you, Tanya. My name is Vardan. I'm an engineering manager on the Grafana Enterprise team. As Tanya has already mentioned, I'm excited to share that fine-grained access control is now available in the Grafana Enterprise as beta. Today, I'd like to give you a brief overview of the new capabilities that fine-grained access control offers, demonstrate how to leverage it, and also talk about next steps in the future. With fine-grained access control, you can manage access securely for your viewers, editors, admins, or Grafana admins with fine-grained permissions to ensure that your users have just the right amount of access within Grafana. The flexible access control model allows you also to create your own custom roles to grant or revoke access to your users. In addition, Grafana Enterprise comes with fixed roles, which bundle together relevant permissions, which allow your users to have seamless experience within Grafana. Fine-grained access control is fully compatible with the Grafana open source permissions model. And last but not least, if you want to create your own custom roles, grant or revoke access to your users, you can use the HTTP API provided by the Grafana Enterprise or Grafana provisioning. Now let's look at the main parts of the fine-grained access control. When an authenticated user tries to access Grafana and perform certain action, the authorization system is going to check if user has the relevant permission to perform that action. If they have, the action will be granted, otherwise it will be denied. Here on the left side, I have listed a couple of permissions as an example, such as send report, read, delete, or create reports, or read or update or create users. You can combine together one or more permissions and map them to a role. In this example, I have a role called report viewer, which has two permissions mapped to it. A user assuming this role will be able to send and read reports. Finally, if you want to grant or revoke access to your users, you can assign or unassign one or more roles to the built-in organization roles, which are viewer, editor, or admin, or to a Grafana admin. I think it's a good time to move to the demo and see how fine-grained access control works in real example. I have already prepared the Grafana dashboard. You have already seen Tanya showing you the reporting and the new enhancement that we are getting with Grafana Enterprise 8. So I'll leverage that and also try to create a report for my Grafana dashboard. Prior to fine-grained access control, only organization admins could create reports. The user I'm using now is a viewer in this organization. So my user can't actually manage reports. They can't create or read reports. What I'm going to do, I'm going to use fine-grained access control and create a custom role, map permissions to my role, which will allow this user to create and read reports. To do so, I will use Grafana provisioning. I have already prepared here a provisioning configuration file with the definition of my custom role. You can see here permissions, and there are two. First, allows user to create report, and second, allows to read reports. Pay attention to the scope here. In this scenario, scope indicates that the user with this permission can read all reports. As an alternative, we can specify in the scope a very specific report, which your user will be able to read. Last, I'm mapping this custom role to an organization viewer role, which was the role that my user had. I'll quit my editor now, and I need to apply the provisioning changes, for which I will use the API endpoint provided by the Grafana Enterprise, which reloads provisioning configuration for the fine-grained access control. I'll go back now to my Grafana instance and refresh. Here, I can already see that I have the reports appearing here, and I already see I need one report which I created prior to this demo with an organization admin user. So first permission checked. Let's now see if the second permission works or not, which should allow us to create a report. You have already seen this page from Tanya's demo, so I'll just simply fill in some details to move on. Let's call this a new report. I need to add a recipient, GrafanaCONline test, and then Grafana grafana.com. And last, I also need to select a dashboard as a source. I should be able to create a report now. Here we go. I was able to do so. So far, so good. Now let's see if I can delete this report. I can already see here that this button is inactive, which means I don't have permissions to delete the report, which makes sense because we only assigned 2 permissions so far. Let's go back to the configuration file and add a permission, which allow our user also to delete this report. I simply need to update the version of my role. And add a relevant action, which will allow to do so. The action in this case is called reports delete. And I'll like my user to be able to delete all the reports. So I'll just use the same scope as I had above. That's it. Should be able to save this file. And I also need to reload the configuration again. So I'll do that. Go back to my Grafana instance, refresh the page. Here we go. I see that the button is now active. Let's try to click this, delete. That worked. Excellent. So we essentially created a custom role, mapped permissions to the role, which allowed our user, who is an organization viewer, to create report, to delete reports, and also to read reports. I hope this demonstrates the capabilities of fine-grained access control. I'll go back to my slides and talk about next steps and the future update. As I mentioned earlier, fine-grained access control currently is in beta. You can manage users' reports with fine-grained permissions. And we made sure that we build the foundation and necessary blocks so that we can evolve the system to the place where fine-grained access control will be the standard and one way to manage access in the Grafana. You will be also able to grant or revoke access directly to your users and teams. And we would also like to give you an opportunity to manage roles, permissions, grant or revoke access via user interface. Finally, fine-grained access control is the first step towards multi-tenant Grafana. With this, I'll end my talk today about fine-grained access control and share more on a personal side and note. The past year was tough for everyone. It was the same for me, and I really couldn't have survived this year without my family, who was always there to make it more bearable for me. Last but not least, thanks to the entire team who worked on this project and made it possible. Thanks for participating. If you are interested in Grafana Enterprise or want to learn more about fine-grained access control, head out to the grafana.com and check out the Grafana Enterprise product page. Thank you.
Alrighty, I hope everyone enjoyed all that.
Hello.
Yes.
Oh,
Now we're into the live Q&A part. So let's see if we can take a look at some of these questions. So I think we'll start with this one right here. Hi there, loving the project. This is from John Rutter. I assume you'll cover this in your presentation, but if not, when can we expect the Grafana 8 image on Docker Hub? So it's already there. It got published yesterday, I believe. It's a little hidden, you know, between the master, main, and all the different, like the latest tags and stuff like that. But it's definitely in there. I just checked right now. So you should be able to pull that directly from Docker Hub. Looks like we got some questions on the library panels. So the first one is, can the library panel be provisioned from file? I don't think it can right now, right? Torco?
yeah, no, it's only through the API right now.
Gotcha. Yeah, there is an API for it. The documentation isn't on the website yet, but it does exist. If you search through the GitHub issues, you'll find some tickets there that that knocked it out. Hopefully, we'll have some documentation for that for you guys soon there. I saw also library panels. Can they be shared with several orgs? How are they managed? that way?
No, I mean, orgs are really separate kind of for like a multi-tenant solution. So they're completely isolated. So you cannot share anything between orgs except users that you can have. So no, but if you provision them through the API, you'd have to create separate ones. Yeah.
Cool. And I saw another follow-up question asking if library panels can be provisioned via Kubernetes config maps. Again, no, not yet.
No.
Not yet. Let's see. I think that's it for the library panel questions. So looking here, some questions on reporting. Reporting looks very useful and updates are clean. Is it still limited to enterprise only? Yes, it's still an enterprise only function. Will the new reporting features be available in Grafana Cloud? I believe so, as long as you have a Grafana Enterprise license on the cloud.
Yes.
Correct me if I'm wrong, Torkel. Cool. Let's see. Can you schedule a report directly to a printer? You probably could. I think it can do email, right? So you can.
Well, yeah, you can use a preview to which will give you the PDF directly, and then you can just print that.
Awesome. And then I think that's it for the reporting questions. Let's see. So in let's go into fine-grained access control. So with the enterprise access control, how can it be used when Grafana is embedded in a dashboard? Or I'm guessing you're talking about possibly embedding Grafana panels outside of Grafana. Is that maybe what this question might be asking? I'm assuming they're talking about using the embedded panel functionality and how will that work with the fine-grained access control?
I mean, well, I guess it doesn't. I mean, if you're embedding Grafana,
like in like a, if you're using like the iframe, maybe.
Yeah. So then it kind of depends on how you set up the auth proxy or whatever authentication you're using for the iframe.
Yeah, it will be interesting to learn about the use case and the problem. So maybe an author of the question can follow up also in Slack.
Great. Can we integrate RBAC with the cloud-based identity providers like Azure Active Directory?
That's a great question. Eventually, yes, that's a problem space we'll be looking at. At the moment, no. Within the beta period, we'll be looking at this problem, but yeah.
Great. And then there's another one: is fine-grained access control available in Grafana Cloud? Yes. Again, I believe so, right? If you.
Yeah. Well, yeah. For the time being, it would be great if customers and users can reach out to our customer support to manage their needs. And then while we are evolving the system and moving towards GA release, it will be, of course, integrating more, and it will be more available in the cloud. At the moment, please reach out to customer support.
Yeah, exactly. While we've released Grafana 8, as far as Grafana Cloud customers, there is a rolling timeline over the next month or so to get folks on Grafana 8. So it won't be immediately upgraded on your instance if you are an existing customer. It's just an FYI there. Let's see. This is related. Today I updated Grafana, but I didn't see the new alerting feature in UI.
Yeah, it's behind a feature toggle. So to try out because the new alerting system really replaces the old one, and we want users to have a choice to kind of try it out and give us feedback. So yeah, it's if you read the changelog or the kind of what's new article, there are guides there for how to enable it and how to try it out.
Cool. Here's a caching question. I can imagine having dashboards with caching enabled, but sometimes I want to update the data. How is this going to work with the last 7 days time ranges?
You could probably try to have two data sources, one cached and one without caching enabled for that.
Awesome. Let's see. Again, is fine-grained access control available in Grafana Cloud Pro or only Enterprise? Is it only Enterprise, Torkel, or?
I think so. I'm not 100% sure, actually.
Yeah,
That one-
there's
Yeah.
Go ahead.
me neither, honestly. It's a good question.
Yeah, no worries. Feel free to send an email to support, or if you're a current customer, feel free to reach out to your customer success manager, and we can guide you through that if you're interested. Let's see. Any new features around alerting? I believe there's a whole entire session that's going to be dedicated to alerting. I don't know if that happened already, or if it's still going to happen. But there's definitely a session
if you're interested in the new alerting system, there's a full session on that. I think next the 16th. I think next Wednesday.
Awesome. Will Grafana 8 support scripted dashboards throughout, and will there be any information on its replacements this week?
I mean, we haven't removed it yet. It's still kind of deprecated, or in a state where we want to replace it with something that solves the same kind of use case, same scenarios that the scripted dashboard feature is trying to solve. But yeah, we haven't done that yet. But it's something we're looking for, maybe for version 9, to have like something that can really replace scripted dashboards, or be a reimagining of it.
Awesome. Again, someone asked us, are there timelines around Grafana 8 features to be available on Grafana Cloud? Like I said, it's going to be a rolling upgrade over the next month or so. I think we'll be any current customers will be communicating on how that will work. But if you want to be proactive and talk to someone, feel free to file a support ticket or talk to your CSM. A fun question: what mic are you using? Very clean sound. I'm using a Rode Reporter microphone. Let's see. Is there a way we can search the panel name in the dashboard? So this is an interesting one. So if you're using a library panel and you search for the panels in the library, it'll actually show you what dashboards it's being used on, and you can jump directly to that dashboard. As far as just searching a panel, just a normal panel in dashboard, I believe that's not there yet, right, Torkel?
No, I mean, you can always use dashboard search, but yeah, in the normal kind of dashboard search feature, you cannot search by using a panel name. But yeah, doing some more radical kind of improvements to search is definitely something that we're looking for, sort of long term, like for V9, is like really reimagining how what you can search on.
This one's a question from RV. Is the AngularJS to React transition complete with the V8 release?
Yes, Grafana itself is now like 99% React, and all the now like core panels except the heat map panel have been migrated to this new new React panel architecture. We still have the old graphs as like an option, because we have not 100% feature parity yet with the new default graph panel that's called time series. So we're still working on like these last final things, but all the pages, the whole app is now 100% React. We will still support obviously Angular plugins for some time. How long is kind of yet to be defined, but yeah, you can kind of consider Angular plugins sort of being deprecated, but we'll have support for potentially a long time to give the community time to migrate their plugins to React.
Awesome. And I think we got time for a couple more questions, so I'll take the ones for caching. So how will caching affect the memory usage?
I will take this question.
So absolutely expect an increase in memory, although the footprint is not large. I cannot come up with the numbers on the spot, but if memory is an issue, use Redis or Memcached as a backend. Also, there are some really basic limits to limit the memory. There is an optional size limit on values, regardless of the backend. So this will allow users to prevent super large queries from being cached into one key. And if you want to know more details, like more in depth of how it's implemented, check out today's session from Kevin Meinhardt on query caching.
Gotcha. And you might have just answered this, but Eric Jenny asked, how will caching affect how data is pulled? How will refreshing work, i.e. how will we know we're seeing the latest data?
You can see it even on the panel. There is a small icon that indicates that the response is coming from the cache on the panel itself. So that's it.
Awesome. And like Tanya said, make sure to check out the session later. It'll be going much more in depth into the query caching. Awesome. I think that's all the time we have for questions. So thanks y'all for joining us on the start of GrafanaCon day 2, and hope you stick around for more of the sessions.
Yeah, thanks.
Thanks.
Thank you.
Hi, everyone. I'm Christine Wang. I'm a senior solutions engineer at Grafana Labs. I'm based out of Los Angeles, and I'm super excited to be here with everyone today. So before we begin, I couldn't have survived this past year without, of course, my husband and son. It was really nice to be able to spend a ton of time with them. And we also adopted a cat a couple months ago. So this is kind of a new thing for me because I previously haven't been a pet mom yet in my adult life. So today I'll be talking about one of my favorite newer enterprise plugins, which is the Jira plugin. And I love it so much because it really highlights and showcases how Grafana is not just used for time series data. You can visualize anything, and in this case, it is your Jira tickets. With our pluggable architecture, you can actually create plugins to query any type of data. So really, the sky's the limit in terms of what is possible to visualize within Grafana. So here we have a dashboard showing you your sprint status that you can easily view and see the status of your sprints and understand the velocity in which your engineers are completing story points and how accurate your team is at estimating story points, so you can fine tune how you plan for future development cycles. If I go into one of these panels here, just to show you what the query editor looks like, today, I'll be talking about one of my favorite newer enterprise plugins, which is the Jira plugin. And I love it so much because it really highlights and showcases how Grafana is not just used for time series data. You can visualize anything, and in this case, it is your Jira tickets. With our pluggable architecture, you can actually create plugins to query any type of data. So really, the sky's the limit in terms of what is possible to visualize within Grafana. We have a dashboard here that is showing you your sprint status, so you can quickly and easily see the status of your sprints and understand the velocity in which your engineers are completing story points, and also how accurate your team is at estimating story points, so you can fine tune how you plan for future development cycles. If I go into this panel here and click on edit, I can show you the editor here. So in this case, it's super simple. We are using JQL, which is Jira Query Language, and I'm just filtering out for project equals EP and type does not equal epic. And then other than that, I can select the fields that I want to visualize. So in this case, it's my story point estimate field. I love this dashboard view because I'm able to correlate Jira data with data in my GitHub repositories that give me much more context on my sprints, such as release dates and information on my pull requests. So GitHub is an open source plugin, and I can easily view different data sources side by side. You can mix open source enterprise data sources, so pull all of that data together to correlate. And as you can see here, I can see who my top GitHub authors are. I can look at my release information. I can also see average open time for my pull requests. And previously, this data may have been siloed and you wouldn't have had that visibility. Other Grafana features that may be useful for a dashboard like this include annotations, where you can easily overlay any type of information against any other type of data. So in this case, I'm actually overlaying release dates against story points created by day. And last, I want to share with you one of my favorite Grafana features, which are transformations. So think of transformations as a way to massage and manipulate your data before it is passed to the visualization layer using SQL type capability. So it allows you to extend what you natively could have done within the other platform. So if I go into a panel like this, which is the velocity, which is sharing the velocity of my sprints, so how many story points I'm able to complete within a sprint, before I transform the data and when I query this directly from Jira, this is what the data looks like. So I see all of my story points here, but it's not condensed, it's not reduced by the sprint name. So it's kind of hard for me to understand. It's very redundant, and I'm really looking for that aggregated view. So what I would do is I can apply the group by transformation. And from here, what I want to do is group by the sprint name. And then for the story point estimate, I can calculate the total. So when I do that, this becomes a lot easier for me to understand. And this panel is much more meaningful now. So that's pretty much all I have for you guys today. Thanks again for joining us. Super excited that you're here for GrafanaCon, and I'm looking forward to what the rest of my colleagues have prepared for you.
Hello, everyone. My name is Kevin Meinhardt. I'm a software engineer on the Grafana Enterprise plugins team. I've spent the last few months working on data source query caching, which is a feature for Grafana Enterprise. What is query caching? Well, a cache is just a temporary store. So query caching temporarily stores the results of a data source query and serves those stored results to very similar queries. Typically, this really only means that people that are looking at the same dashboard will ever see cache results. But that does mean that they will also send fewer queries altogether. Naturally, this sending fewer queries has some nice upsides, especially when working with some slower data sources or ones that are metered, as in like they have rate limits or they cost money to send queries to. Caching can be configured to store data in Redis, memcached, and in-memory backends. The Redis and memcached are particularly good if you're hosting your own Grafana instance, or in-memory if you just want to test something out, or if it's just a smaller installation. For things like limiting the amount of memory that's used by the cache service, it's important to use something like Redis or memcache that actually gives you that kind of control. It has an HTTP API for enabling, disabling, or updating query caching per data source. Currently provisioning a data source with caching enabled is not yet supported. However, that is coming up in a later release. We'll talk more about what is going to be released or what features are coming up for caching in a later slide. But because of the nature of Grafana and the real-time monitoring space, caching isn't generally that useful for speeding up slow queries, especially since most of the data that you care about is going to be stuff that's most recent, as in we've never even asked for it before. I think the way that caching affects performance will be a lot clearer whenever we start looking at an example. So let's look at one. Here I've created a small dashboard with 3 panels. Each of them have 3 queries to 3 different data sources. And I have my dashboard set up to refresh every 30 seconds. For the sake of experiment, imagine we have 4 people all looking at the same dashboard. And this could even be like, think of it like 4 TVs, just in kiosk mode, refreshing every 30 seconds. So without caching, this would be 36 queries per 30 seconds. With caching, however, we should only really need to make these requests once. So that really should just be 9 per 30 seconds, no matter what. It doesn't matter how many people are looking at it. So let's look at the metrics for that and see how it performs without caching. And it's about what we would expect, right? This data source in particular is quite slow. I know that it's slow because I added a 5-second wait after every request. So I wanted to make sure that it was slow. But in our heat map, we can see at the highest end, we have about what we calculated, about 36 plus a little bit extra for the Prometheus queries and all that. So, and it's definitely on the upper end of our slowness. Tania already showed you how to enable caching and how to identify when a panel's data comes from a cache data source or comes from a cache response. So let's look at how caching can affect query performance. Before we go on to the next slide, one thing that's important to note is that caching does not affect your average request duration. That metric is actually not recorded when you get a cache response. Instead, what you'll see is just a reduced total query count, because that's kind of more accurate to what's happening, right? The data source did not get faster. It just reduced the amount of queries that were being sent. So as you can see, like I said, our average request duration is still about the same, pretty slow, 6.5 seconds. In a production environment, that's something that I would probably want to address. However, I think the real interesting thing is that there were significantly fewer requests sent overall, our upper end being 19. And that's only at in a few blocks, in a few intervals. If I look at the real fun metric, the number of cache hits, it looks like I managed to save about 5.5 thousand requests. Those are just requests that got data but didn't actually need to be sent to the data source. This is especially nice with, like I said, GitHub, which will limit you to 5,000 per hour. So it's possible that this could have completely saved me from even seeing an error about using too many requests for my access token. So clearly for metered data sources, it can have a pretty enormous impact. And if you look at the cache latency, or caching overhead, this comes at almost very little cost. So as mentioned before, with the flexible configuration, there's also ways to affect how frequently cached responses are given to people that request them. This can be done by controlling your interval. Because interval is a calculation of your time range divided by your max data points. If you decrease your max data points, that will increase your interval, and then that will mean that you will be serving cached responses for longer amounts of time. So in the top example, I would be sending a cache response and fetching a new one every 5 seconds. Whereas in the bottom example, I've decreased my max data points to 50, meaning I will see less points on the graph. However, because my interval is 1 minute, they will be stored for an entire minute before a new request is sent to get more fresh data. This can be especially useful for expensive queries that you really don't want to send more than once every minute or every 5 minutes. So some of the upcoming additions for this feature for caching is we want users to be able to provision their data sources with caching enabled, because we know that it's a little bit cumbersome to go into the data source settings for every single data source and click enable. We want to cache values that are populating dropdowns in query editors. This will help decrease the load on certain plugins that require a lot of information to render a query editor, especially ones like ServiceNow, which can have just massive amounts of data in a single dropdown. We want to cache incremental data rather than an entire query. This could actually have a pretty huge impact on query performance, but it also introduces some additional requirements on every data source. So it may not be possible for this to exist for every data source. It might have to be implemented for each one at a time. So thank you everybody for attending. I hope you find this feature to be as useful as I did, because that's why I built it. Enjoy the rest of your GrafanaCon.
Hello and welcome to GrafanaCon. My name is Mikhail Volkov, and today I'm going to talk about Redis plugins and how plugins connect Grafana to Redis in new ways. Grafana supports 3 types of plugins: data sources, panels, and application plugins. There are 103 data sources, including data sources based on the backend platform introduced in Grafana 7, 87 panels, and 18 application plugins. And I hope to see more application plugins soon based on the React router introduced in Grafana 8. What can you do with Grafana plugins? Grafana can access application and databases based on HTTP protocol like Prometheus or backend data source based on Redis. Then this data can be visualized using built-in panels like time series, custom panels with the bars, custom elements, new introduced Grafana panel, application pages, or custom panels using images. And all this information provided to the end users. Redis plugins for Grafana is the only direct way to stream and monitor Redis application data in real time via Grafana dashboard. We introduce Redis data source to retrieve information from Redis database and Redis modules, and then to elevate Redis experience in Grafana, we introduce Redis application plugins. The latest plugin we introduce is the Redis Explorer. Redis data source able to connect to Redis open source or Redis databases managed by Redis Enterprise. Redis application plugin provides application pages, dashboards, and a custom panels for Redis data source. There are 4 custom panels: Redis CLI, command line interface, which help you to interact with your database, Redis latency panel, Redis max memory keys, and Redis gear script editor. And the last plugin is Redis Explorer, able to connect to Redis enterprise software clusters. For that, it uses its own data source and provide application pages to add Redis data sources. Redis plugins ecosystem supplements the capability of Prometheus. And Prometheus can gather information from Redis and Redis Enterprise using the Redis exporter for metrics and using Redis Enterprise metrics exporter. Combined with the metrics from Prometheus and the real-time application data, which can be streamed with the custom panels on the same dashboard, can show you and provide you the full picture of your application. To find the biggest keys in your database, you have to scan through the key space in Redis. To do that, we created Redis Max Memory Keys panel, which query backend data source to accumulate results, and sort keys consumes the most memory in your database. Backend part of your data source is stateless, and such logic has to be implemented on the front end. Also, backend can implement additional logic. In our case, we implemented a command called tmscan, which combines 3 different commands: scan, memory usage, and a type. And this panel can be displayed on the same dashboard with this database metrics like latency, operation per second. And because this operation can increase latency, you can monitor it on the same dashboard. Another panel I want to discuss today is the Redis Gear script editor. Redis Gears is a dynamic framework that implements data flow in Redis. And this panel allows you to edit and execute this function in blocking and unblocking mode. And having this panel with application data, with additional panels, can streamline your workflow to deploy and develop your applications. One of the recent projects we did based on Grafana and Redis is the forecasting stocks and the crypto prices. Historical data for the stocks and the crypto can be ingested using Node.js application, or it can be retrieved using APIs. Then this information can be predicted based on the Facebook profit library. To do the prediction, we created a special dashboard with a time series which display historical data, with a Redis Gear script editor, which has this function, which can be modified to do the prediction for 30 days, 90 days, or a year. And then this profit model should be trained. So you can easily do multiple interaction and train your model to get most accurate results, everything based on Grafana on the same dashboard. Can you spot Batman with a bat camera powered by Grafana? This project is about analyzing camera feed using Redis AI and OpenCV library. For this project, we use IoT camera based on Raspberry Pi, and as we know, Grafana can run on Raspberry Pi. Camera feed saves the live stream feed as a Redis streams, which process in event mode as Redis Gears module, and then it's analyzed by Redis AI. The metrics saved as a time series and resulted images analyzed saved as a Redis time series, Redis streams. On this dashboard, you can see there is a special image panel which shows you the live feed, and there are metrics about the process. How many people was counted, what's the processing time, how many frames in the queue. And there is a Redis Gears script editor, which allows you to modify your scripts and change the logic in real time. When we look at Grafana Marketplace to find a panel which allows you to display the images, we cannot find it. So we created one following documentation from Grafana.com. And this panel received base64 or bytes images from a data source. And because Redis supports streaming mode and allow it to refresh the panels without refreshing the dashboard, it can show your feed in real time. And also this dashboard provides information, how many frames in the queue needs to be processed, if there is any delay, and how many people was found in the frame. Let's do the live demo. And this is my bed camera. As I said, it's a Raspberry Pi in a Lego case, and it has a camera module on the back. So if I turn it around, you will see the live feed from the camera. It's able to track my face, and it shows you the number of frames which is processing and how many people was found in the frame. And it's a bed camera. The plugins let you achieve everything without having to switch between multiple applications or export data from one application to bring it into another. All the increased functionality comes with a more streamlined workflow. If you have any questions about Redis plugins or any plugins development, you are welcome to ask me in Twitter at Mikhail Volkov and follow our projects at volkovlabs.com. Thank you and enjoy GrafanaCon.
My name is Stephanie Clausen, and I am a developer on our enterprise plugin squad. I've been with Grafana for a couple of years now, and I am talking to you today about data source plugin query editors. I want to give you some guidelines and best practices, and this is what's worked for me. As always, these are guidelines, these are not rules. Every data source is different, and so at the end of the day, it's really important that you do what works for your particular use case. With that said, these guidelines have really worked for me, and I think if you follow them, you'll have a really easy to use yet powerful query editor. Also, the users here, if you're a plugin user, please pipe in, especially if you agree with what I'm saying, or actually even if you disagree with what I'm saying. It's really important that we focus on getting good plugin query editors. That's the intent. All right, so number one, stick to using Grafana UI. There's lots of UI controls out there. Grafana UI may not have everything that you need, but there's sure a lot of stuff. And if it doesn't, if you can think around it, or maybe look what's available and try to use what's available, you're going to have a much more cohesive, native looking query editor, which I think is really, really important, especially when it comes to moving between the dark theme and the light theme. Using Grafana's built-in UI controls, that the switching between the themes is built into them. Go to developers.grafana.com. It's all documented there. Click on the Docs tab right here to see how you can use it in your React control. Even test out the theme right here by clicking on it, and it'll go back between dark and light. So the cluttered room versus the empty room. Look at both of these rooms. Both of them, if they were a query editor, the top one would simply have too many options. The bottom wouldn't have enough. The balance is trying to find a powerful query editor that's easy to use. How do we do that? I think the best is just going to be to show you an example. And I think kudos goes out to Marcus Olson. I think he's done an excellent job in his JSON plugin of writing a really, really great UI. So I'm just going to take you there. What I'm particularly impressed about in this particular query editor is the grouping, and I think this is this should be a standard for plugins to group all of the options together. So if you're working with headers, all of the header options are here. If you're working with HTML in this case, having everything for the body is right here. And even some experimental options with an appropriate warning. Really, really well thought out. Another thing that I want to bring to your attention is helping the user, giving them answers, even if they didn't really ask for it. If I hit dot right here, this query editor is going to give me potential options that I can select. Geo level. And in this case, my original one I selected was classification code. This makes it so much easier to use and navigate that. We want the query editor to be usable by not just experts, by anyone. It should guide you through the process and essentially create some curiosity around the data. Okay, so let's talk about what you see is what you get. This has been when you talk about a GUI, WYSIWYG is kind of a common acronym that I've heard over the years. Essentially seeing, but really the part that I want to focus on is that what the options that are available aren't going to be hidden behind a right click or a left click. They're going to be visible on the page. I think that's really important. Now I can mock my own plugin. I wrote the Dynatrace plugin, and I am going to be changing this, but for the purposes of this demo, I'm just going to add a filter to show you what I mean. This has been a long time standard in Grafana. It's used all over the place. There's no indication here where I need to click to remove this particular filter. It is under host. That's where I can remove it. But it would be so much easier if I had it built into the entry itself. Okay, next, let's talk about giving feedback and trying to recover from errors, giving guidance to your user. So most errors might not be really that serious. And so I think it's really important that we don't scare users by displaying errors too quickly. It's really important that we as query editor developers try to understand the errors and guide the user through them. It's only when that error is completely fatal that we should be displaying that. So what do I mean by this? I'll take you through an example. Going back to the Dynatrace plugin, and I'm querying 90 days of data here. If I go to problems, I get an error. Now I have to hover over to see this error. And so if the user didn't know to hover over this, they might just look and say something is wrong. I don't know what is wrong. And then be inclined to not interact with the query editor anymore. When really the message is actually quite simple. I just need to go below 30 days. So if I do that, then boom, I've got my query back. That's good, but there's a better here. We can do better. And that is, we could also actually query the data for 30 days. We could interpret that message ourselves and then send the user a warning. We've selected the amount that Dynatrace will allow. You can remove the warning by taking your query down from 90 days to 30 days. That's the more ideal solution. Finally, know your API. This is really, really important because APIs can be expensive, especially for big systems like Dynatrace. If you are sending thousands and thousands of queries, you might want to consider having a query caching layer. And that's sort of, I won't get into too many details around that, but I just think it's really important to that the user understands the impact. They should have to understand the impact of using the query editor. And so understand your API. Another option is a thing to think about is your API limited in some way? So and what this means is, am I allowed only 20 requests or 100 requests per minute? If that's the case, I may want to be very careful about sending too many requests, or I might want to space them out a little bit. A particular problem that I think about is the alias problem, and I'm just going to go through it real quick. In Dynatrace, I've put a button here. So when the user is typing in something, anytime they type a key, that could send the query to the query editor. Instead, I've opted not to do that, giving the user an apply button. So they type in their host, they hit apply, their alias gets changed. Likewise, when they remove the host, they get an apply button. This is where the request gets sent off. So it's only sent once. Finally, is your API responsive? If you've got a million metrics you've downloaded, please don't put them all in the browser to be rendered. It's going to be a real mess. Find some way to break up the response. Pagination is another way. Using some sort of a cascader is another way. Either way, make sure that it's responsive. Your UI needs to be responsive. So good query editors, in summary, are both simple and powerful. They take advantage of the available space and they encourage curiosity and exploration. Let's, as query editor developers, let's take the red out of errors. Let's not scare our users when errors come up. Let's guide them through solving their error right inside of the query editor. Thanks for listening. Looking forward to hearing your comments. Thank you very much for listening.
All right. Hey, everyone. Looks like we got a few questions already. First one is about query caching. Data source query caching is only available for Grafana Enterprise. Yes, it is only available for Grafana Enterprise. The second question, how do you get a plugin featured in the grafana.com directory? Mikhail, you've worked on plugins lately.
Yeah, it's actually very easy to get your plugin featured on grafana.com. As soon as you're ready with your plugin development, you have to sign your plugin. To sign that, you need special permission and you have to decide what kind of license your plugin is applicable to. It can be commercial, it can be private, or it can be community. Then you go to Grafana plugin repository, Grafana plugin repository, and you submit your pull request with your plugin. And then also when you submit your, before you submit your plugin, you have to validate that it's according to all the rules. It can be published, and then it's going to be under review. And if the review passed, your plugin will appear on grafana.com, and it can be installed in Grafana OSS, Grafana Enterprise, and Grafana Cloud.
Awesome. The next one is in the data source insights. Can we know which dashboard or panels are hitting it the most? It will be useful to apply the caching to those queries and reduce API costs.
Yeah, I can take that. So data or just meta analytics or insights in general are an enterprise feature, and you actually have access to your insights on different levels. So the first one is you have insights directly from your dashboard view. You can also see insights on your data sources. And so you can see how many requests are hitting it, errors, and latency. So this specific question is, how do I see something a little bit more granular than that? And so as of Grafana 7.0, you can actually export your insights to Loki. So you can run a really quick instance of Loki, and then using Loki as a data source, you can build a dashboard that can leverage all of your meta analytics and insights together in a dashboard. And I was taking a quick look, and I believe you can achieve what you are looking for. So the answer is export it to Loki, and then from there, you can select something a little bit more granular.
Awesome. Looks like the last question we have, if no more come up, how does the AGPL3 relicensing affect plugin development for one's clients using Grafana OSS? So the AGPL license change does not affect your plugins almost at all. Any of the libraries that you would be importing are still licensed under the Apache 2 license. And then since your plugins aren't an extension of Grafana, really, and they're not licensed under AGPL either. So you're in the clear. I would still take a look at the licenses of the code that you're importing, but all right. I think that's all the questions, if none are coming up. Oh, here's one. Anyone have any advice on updating an older panel plugin from Angular to React?
I can make a quick comment there. Yeah, I wish we had some, line items that you could go through and tell you exactly how to do it. I have done a couple of these, and the easiest way for me was to actually template a new plugin using React and just start copying and pasting code across. I wish it was easier than that, but that's probably the easiest way right now.
Yeah, I don't have a lot of experience doing that either. It's
I started with React only.
Yeah, me too.
Yeah.
Any thoughts on choosing between writing a front end or a back end plugin? And any tips for migrating a front end plugin to the back end? I'll just say one little thing. I just like writing back end plugins a little bit more because I like Go, but that's pretty much it.
They have actually different purposes. I can maybe talk a little bit about it, because when you write the backend plugin, you still have a front end part. But the main advantages of having a backend plugin that if you have any application or database which does not support HTTP, you have to write a backend plugin. There is no other way to do that. And as I said in my presentation, you can implement also additional logic, additional commands, anything you want. So to take it on yourself. But at the same time, when you implement the backend plugin, you have a front-end part which have to provide this information to the panels, right? So, and you have to decide what kind of logic you want to implement on the backend side or on the front-end side. And if it supports HTTP, you're good with the front end in most cases only.
One more further comment on that would be that certainly recommend backend plugins. In any case, if you are looking to have alerting done through Grafana, you will need to pass your data back through Grafana, and that's only done with a backend plugin. So you'll get the alerting for free if you write a backend for your plugin.
Okay.
Yeah. Also, real quick, we are kind of extending the feature set of backend plugins that return data frames for things like query caching, because that will only support backend plugins currently. So this looks like a pretty good question. When to expect having caching in fields for ServiceNow plugins? This is a really heavy in the number of API queries in my environment. Yeah, this is something that we are aware of. And so this is the caching resource calls that I mentioned in the presentation. When we can expect it, I'm not totally sure, but I would expect it at some point. It's coming. It's something that we're totally aware of. Let's see. I tried to install the MQTT data source several times with no success. I would strongly suggest trying to get a hold of the community or the Grafana community discourse, I believe, where you'll have a lot more knowledgeable people. You might even find the person who wrote that plugin. What are the best ways to showcase a single dashboard with many metrics running in the background for a go/no-go overview? Anybody want to take that one?
Maybe I can try. I'm not sure, but if you're doing like a more high level overview of something, like let's say green is healthy, red is not. We typically see a lot of users, and I like to use the stat panel. So the stat panel allows you to create aggregations or choose one of the results, and then you also can apply thresholds for that. So it makes it really easy for your viewers to understand that data.
Yeah.
And also add to that as well that the Grafana 8 introduced new way to value, to add the value, right? So if you have a failed or okay, you can actually mark it in the colors as well, which is great. Before that, it was possible only with the numbers. So stats is a good way to go.
And lots of panels have, you can add hyperlinks. So this is a really great feature if you're looking to drill down into other dashboards. So having something that is more of an overview, but allowing the user to click on hyperlinks to drill down into other dashboards is going to make navigating through anything that's red a lot easier and more intuitive for your users.
Awesome. Yeah. I think that's all the time we have for questions. Thanks for the questions, everyone.
Thank you, everyone. Bye.
Bye, everyone.
Bye, everyone.
Hello, everyone. Thanks for tuning into our session on Prometheus and Cortex innovation. I'm Gautam, and I've been contributing to the Prometheus community for the last 5 years now, and every single year things get more exciting. So let's just dive in. So I'm going to cover a few statistics on the Prometheus activity, and then I'm going to highlight 3 features that I'm really passionate about, and I'm going to end with how you can get involved with the Prometheus community. Cool. So Prometheus has started in November of 2012. So it's nearly 9 years old now. Having said that, every year the activity and innovation in Prometheus is only increasing. So if you look at the Prometheus GitHub activity over the last 5 years, you can only see that it's increasing and it has shown no signs of slowing down. Cool. So what is all this activity about? There's a lot of things happening, but I don't have a lot of time, so I'm only going to cover 3 things. The first thing is the new UI. So since like 2017 or 2018, when I started using Prometheus, we had a basic Bootstrap and jQuery based UI that worked really well. Having said that, it stagnated and there wasn't a lot of innovation or contributions to it. So we wanted to see if we can do better. So Julius rewrote the Prometheus UI in React, and this is basically how the new UI looks like. Doing this has enabled a lot of community contributions, and we are seeing a lot of exciting features being added to the UI. Well, the most exciting is dark mode. Yes, with Prometheus, you can now have a dark mode option if you prefer that. But a lot of other useful things are being added, like the metrics explorer, which kind of helps you understand what metrics you have in your system and what their type and help information is. The one thing that we're actively working on is improving our query editor to be more intelligent. It does much better autocomplete. It also has help and type information that's super useful. This is something we've been doing in Grafana for a while, but I'm really excited to see this come into Prometheus's native UI. So if you're a Prometheus developer, if you're a front-end developer or a React developer, we have a lot of issues around this UI. Of course, it's a new UI. We're still finding more and more issues, and we want to add more and more features. So if you're a front-end developer looking to get involved, just look at our issue stacked component React UI. And even if you're getting started or you're not familiar with how the Prometheus development workflow works, you can start by picking a low-hanging fruit or a Hacktoberfest issue where you don't need a lot of context to kind of fix these issues. So yeah, if you're a front-end developer and are looking to get involved, just go to our GitHub and try to help us improve our UI. The next thing I want to cover is histograms. So Beyond, another Prometheus maintainer, is really passionate about histograms, has been thinking about histograms for a long time. Having said that, over the last 1.5 to 2 years, he has intensified his efforts into finding a better data model for Prometheus histograms, and he has given a series of talks around this. The first one the first talk would be in FOSDEM, where he shared the history of Prometheus histograms and why they are the way they are. And in 2019, he kind of gave us a small glimpse into how the future of Prometheus histograms could look like. After a lot more experimentation, he gave us a better glimpse into what the future looks like in KubeCon last year. And he has since recently published a really nice design doc on how to do sparse high-resolution histograms in Prometheus. So this, if implemented, will let you have thousands of bucket values in your histograms while making them very cheap in Prometheus. We've accepted this as part of in our dev summit, and Beyond is really busy working on implementing this. I think once this is implemented, it just improves the power of Prometheus by a ton, and I'm really excited about it. The other thing I wanted to cover is exemplars. I look at a lot of latency dashboards, and whenever there's a spike in latency, the best way to debug this is by using traces. Having said that, it's not very straightforward to go from a spike in latency metrics to traces. So we started working on exemplars. Prometheus can now store trace IDs in exemplars and then expose it so that UIs like Grafana and the Prometheus UI can help you directly jump from metrics to traces. I don't want to spoil too much because tomorrow the Grafana tracing team is giving a talk on this. There'll be an awesome demo around exemplars and all the work that we've been doing into Prometheus. So if you're interested in exemplars and Prometheus, please tune into this session tomorrow. Cool. With that, I wanted to spend some time to cover how you can get involved in the Prometheus community. So we have a really nice resource here at prometheus.io/community, which shows you all the channels that we have where you can get involved and how to get started with Prometheus. But one thing I wanted to highlight is the dev summits that we have. So essentially, before Corona, we used to have dev summits in person once or twice a year. But after Corona, I think we're having monthly dev summits where anybody can get involved, anybody can tune in and participate and give their opinions. We've had a lot of progress in these dev summits. We had consensus on implementing a lot of features. Having said that, a lot of these features are still yet to be implemented, even though we decided to implement them. So, and we're looking for help around these. Some of the key features that I want to highlight are like Prometheus can now accept remote write. This feature has been implemented. We're building a Prometheus agent. This is a work in progress PR. We've added SIG-v4 and SIG-v4 authentication to remote write, and we want to also add OIDC authentication to remote write. So if that's something that interests you, please contribute. We want to add dynamic retention and downsampling into Prometheus. So if you want to implement any of these, please feel free to get involved. I'll cover how you can do that soon. A few more things. We now support adding more service discovery and alert notification mechanisms in Prometheus. So if you want to have native service discovery, or if you want to stop using one of your webhooks for your alert manager, maybe you can get involved by adding that integration. We also have Prometheus community with a lot of exporters and other community projects. That's one way, that's one avenue where you can get involved as well. So now you're trying to contribute, but you're stuck with something and you want to talk to a maintainer. We have office hours every week where you can directly talk to the maintainers. It happens every Monday. It alternates between 10 UTC and 17 UTC, so you can attend it wherever you are, no matter the time zone. And we also have some really nice mailing lists and other resources where you can directly contact the maintainers. Cool. With that, I want to hand it over to Christian to see what is brewing in the Cortex community. Thank you.
Thank you, Gotham. It's great to see that so many new features made it into Prometheus, and especially because, yeah, I'm going to be talking about Cortex, which is a long-term storage solution for Prometheus metrics. Cortex is also the main building block for Grafana Enterprise Metrics, or short GEM, which powers both Grafana Cloud and is also available for on-premises users. So I'm going to show how a Cortex open source user is benefiting from the work that I'm, Christian Simon, doing as a software engineer on the Grafana Enterprise Metrics team. I'm going to focus on the feature of cross-tenant query federation today, and I want to kind of head straight into the details there. So we can see in this case, there are two teams that want to kind of store metrics in Cortex, and it's the R&D and the finance team, and there is kind of a central Cortex cluster. So in this setup, there's the requirement that the R&D team can only see their metrics when querying back, but the leadership team should be able to see kind of both the R&D and the finances team's metrics when they query. And yeah, to solve that kind of use case, we make sure that every team uses their own kind of soft tenant to write the metrics into Cortex. And basically then, when it comes to querying, we use the single tenant for the R&D team, which basically gives them all of their metrics. And the leadership team can use cross-tenant query federation to aggregate the results from both the R&D and the finance team. So let's look at a quick example. So in this case, we query for the Go version that are kind of scraped, and we assume we are part of the leadership team and maybe looking after the security and want to figure out which Go versions are used in our environments. And here we can see that, for example, here there's one instance of a Go 1.14.4 application running, and that might be something that might be important to update because there might be some security problem with that release. So now I want to take a look at how the gem cross-cluster query federation feature does the same thing, but on multiple cluster level. So especially in enterprises, there are a lot of good reasons and valid reasons why you need to run multiple Cortex clusters. So it could be for regulatory compliance requirements. You also might want to be able to kind of be resilient across regional failures, and also maybe you just want to be closer to your metric ingesters or your metric users, and that's maybe why you want to run 2 Cortex clusters. And then Grafana Enterprise Metrics provides you with a federation front end that does the aggregation across those 2 clusters in this example, n clusters in general. And as we've seen before, you are able to kind of query them like as they would be all one cluster. And that is something that we've learned from our close relationships with our enterprise customers. And because we saw this as a quite niche feature that only really large businesses can benefit of, we decided to keep that kind of in the Grafana Enterprise Metrics part. So to summarize, you should totally use cross-tenant query federation because it allows you to separate out your teams and aggregate them whenever you want to do that, and maybe have some form of different access roles to your metrics. Grafana Enterprise Metrics is based on the code of Cortex, and basically through that, with our investment into keeping our Grafana Enterprise Metrics customers happy, we also often, as a side effect, improve the situation for the general Cortex open source user. So up next is Suraj, who will talk about how Grafana Cloud Synthetic Monitoring utilizes Prometheus, Cortex, and Loki, so it can enable you to easily monitor the uptime of your own web services.
Thanks, Christian. Metrics, logs, and traces tell us what's going inside our services. But do you know how your service is doing from your user's point of view? Hello, everyone. My name is Suraj. I'm a software engineer working on Grafana Cloud. Let's talk about synthetic monitoring and how you can use to monitor your services from your user's point of view. Before I talk about synthetic monitoring, I would like to talk about black box monitoring as a concept. Black box monitoring is when we monitor your applications from our user's point of view. We pretend to be a user. We come to the application and see how our application is doing. Is it up? Is it returning the expected response? And all that. After all, your users don't really care if your fancy new Kubernetes cluster is up and running. All they care about is the service as a whole. Black box monitoring comes in handy when you have questions like, why is my service up in one region, not in another? Though you can answer that from white box monitoring. Let's consider another question. Why is my service slow in one region, not in another region? In Prometheus world, we have black box exporter. It can do probes to your services over HTTP, HTTPS, DNS, TCP, and ICMP, and generate Prometheus metrics from the probe results. Grafana Cloud's synthetic monitoring builds on top of black box exporter, makes it easy for you to monitor your service from all over the world. We got a nice UI to manage checks. We operate probes all over the globe to run those checks and push data directly to your Grafana Cloud metrics and logs instances. All you have to do is create a check, select locations where you want to execute it from, and hit save. You'll start getting Prometheus metrics and check logs into your Grafana Cloud account. In case you want to run your checks against your internal applications or from a specific location, got that covered too. You can use synthetic monitoring private probes to host a probe on your infrastructure and use synthetic monitoring UI to manage those checks. All you have to do is assign checks to that probe, and synthetic monitoring will execute those checks for you. Since synthetic monitoring builds on top of Black Box Exporter, we expose all the nice, and handy features of Black Box Exporter. You can do all the things that you can do in Black Box Exporter, like regular expression match, check for SSL certificate, check for specific response, provide authentication settings for your checks. And since Black Box Exporter gives us Prometheus metrics, you can mix and match your white box Prometheus metrics along with your black box Prometheus metrics and build nice dashboards in Grafana. Since these are Prometheus metrics, you can use Alert Manager to create and manage alerts on top of your black box monitoring data. You don't really have to set up another alerting infrastructure if you want to get. You can, if you're using Grafana Cloud, you will have Cloud Alert Manager to execute those alerts for you. And that's not all. We have something else that we've been working on. We've been planning and building traceroute features in synthetic monitoring. Traceroute is really useful when you want to see why your application is slow in some parts of the world and where that time is going. Next up, Russ will show you synthetic monitoring in action and give you a sneak preview of what's next for synthetic monitoring.
Howdy and welcome. We're going to dive into setting up and using synthetic monitoring in Grafana Cloud. My name is Russ. I'm on the synthetic monitoring team here at Grafana Labs. And let's dive right in. I'm looking at my Grafana Cloud portal at the moment, and synthetic monitoring is available over here in the left sidebar. It's installed by default, so you don't need to do anything to get in there in the first place. But you do need to create a check in order to get data flowing into the system. There are 4 types of checks at the moment, and they're all based on Prometheus Black Box Exporter, which means that they produce Prometheus metrics, which we can use to query or build dashboards around. I'm going to use a TCP check, and I'm going to call it my TCP check 1. And I'm going to point that at a target. And then I'm going to select where in the world I want these checks to run. There's a bunch of options. I'm just going to select all of them. So it's running from all over the world. Then there's a bunch of settings and configurations. All the settings and configurations are specific to the type of check and sort of what makes sense and how to build the request it's sending and what constitutes success in the response. All of the settings available in Black Box Exporter are also available in synthetic monitoring. I'm going to leave the defaults for now. The alerting setting is when I do want to call out though. So you can associate an alert sensitivity level with a check. And this doesn't create an alert, but it does create a metric label and value that you can use down the line for Prometheus style alerting. I'm going to hit save there, and what that's done is that sent that configuration out to all the probes, and they took that in and they're spinning up. They're starting to send requests to that endpoint. They're going to measure how that goes and produce Prometheus metrics and Loki logs and send those up to Grafana Cloud for us. So that process takes a second. And while that's happening, let's dive into how we would create an alert for this check. The first step we need to do is create some default alerts. And that's all we need to do. We've associated a low sensitivity with that check we just made, and that will map it to this low sensitivity alert rule. And that's basically just saying that if the success rate of the check drops below 75% for 5 minutes, then we should fire an alert. These are Prometheus style alerts, and they're configurable here. They're also configurable in Grafana Cloud Alerting, where you have access to all the power and flexibility of Prometheus style alerting in Grafana Cloud. So here we can see these same rules. I just popped over to the Grafana Cloud Alerting plugin. You can see all these alert rules expressed in their sort of raw configuration format, and you can edit them here if you like. And then you can route them to any notification receivers that you want. So let's head back to synthetic monitoring. It looks like the data has started to flow back in for our check here. And we can see it's not doing too well. It's only at a 54% success rate. So we need to check out why that might be. Synthetic monitoring comes with dashboards for each check type out of the box. So this is our TCP dashboard. And we can see that we're having some problems based on geography here. So in London, our error rate is 0%, but in Paris, our error rate is 100%. So there's something going on here that's based on the geography and where the request is originating. And this can be something that's hard to figure out with traditional white box monitoring that synthetic monitoring can help you with. We also get performance based on location. So let's say in Frankfurt, it looks like things are slow, but things are pretty quick in San Francisco. So that might be something we're concerned about. You also get the raw Loki logs here in the dashboard to see why things might be failing in Paris or anywhere else, and to diagnose problems. So that's it. That's how to set up a check and create alerts and troubleshoot problems in synthetic monitoring. Thanks a bunch.
Hey everyone, my name is Jacob Plick, Senior Cloud Integrations Engineer here at Grafana Labs, here to talk to you a little bit about Grafana Cloud integrations and what they look like, and maybe a little bit about what we have in store with them. But before we get into that, so I have to acknowledge that without the online TTRPG community that I found, my need to connect with people as a mega extrovert would have been an abysmal experience the last year or so. And I'm incredibly grateful to have found a community on the interwebs to connect, play games, tell some really cool stories, fight some dragons. So sort of a sequel to my Observability Con talk, as I wanted to play Dungeons and Dragons in person. Almost there, hopefully. So when we start to build a system and we start to think about ways that we need to observe it, that's when we start thinking about what our observability stack is going to look like. Is there a Prometheus exporter that I need to use that exposes the metrics that I'm using? Do I need to install Prometheus from the ground up, or just use the Grafana agent when it comes to scraping those metrics? How do I visualize this data in Grafana? How many dashboards do I need? Which ones are important? How do I avoid having that 1 million dashboard fatigue, so all the things that I'm seeing ends up meaning nothing? And then alerts. How do I get ahead of alert fatigue by spinning things up from the ground up and making sure that I'm only being alerted on things that I want to be alerted? So configuring all of this, connecting everything together, all of that requires a lot of knowledge, and it can be really tedious and time consuming to spin up on your own. So this is where Grafana Cloud Integrations comes in. So we hear this word a lot in our industry, not just monitoring or observability, but overarching in the tech world. So let's talk a little bit about what that means for Grafana. So at Grafana Labs, our integrations take the Grafana agent, our tailored Grafana dashboards that we've built for you, and some alerting defaults for common observability targets like Linux hosts, Kubernetes clusters, console for service discovery, etcd, those types of things, as well as a pre-configured Prometheus and Grafana-based observability stack. So that way you can get up and running in minutes, and that way you're not having to worry about what else you need to do. So let's show you a little bit of what that looks like. So here I have a little bitty Kubernetes cluster. It's running locally on my MacBook here. We have a few pods and services running. And then if we come over to Grafana, I have a Grafana cloud instance that I spun up for this purpose. And if I click on that little lightning bolt on the left-hand side, that'll take me to our onboarding walkthrough for integrations. As you can see, we have a list of things in which to get things set up. But I'm going to go ahead and select the Kubernetes service here. And typically, we have a few things we need to do. Pick a service, configure it, and then we'll be able to see our dashboards that we've already configured for you. So kubectl is a prerequisite for this. I've already shown that that's set up on my laptop there. And then I just need to install the Grafana agent, which I can do simply by copying this command here. This is something I did ahead of time just to save a little bit of time. And then also on the same token, configure the Grafana agent. And of course, this is set to go in the default namespace, but I have the ability to change it to a different namespace if I'd like. And of course, any changes I need to make in regards to that change, let's make sure that I hit that as well. And then I just need to restart the agent. So this typically will take a minute in order to make sure that your data is getting collected and set up your dashboards. But for the purposes of time, I went ahead and set that up. So I can either head over to my alerts or click on these dashboards, which we've already have set up for us. So we'll select a couple so we can dive in and take a look at that. Now, there's a bit of a variance here as I was testing out a few things and spinning up the agent again. But just to show you a little bit of data for over the last few minutes of CPU and memory requests at the cluster level, as well as some of our fun little networking pieces in Kubernetes, the pods that I have running, that container, and then a few operational metrics around availability. And then, well, I'll just show you one more. Let's take a look at the pod level pieces. So same variance there. And up at the top, I have the particular, in this case, the Grafana agent selected. So let's show you something maybe a little bit more interesting. Yeah, node exporter makes sense. And then that's the CPU memory usage from that perspective, as well as some of the networking pieces there too. So lots of places for me to get started, all with really a few clicks. But don't forget, let's take a look at that alerting setup as well. That's the config I have set up. And eventually I'll head over to the rules so you can see what that looks like too. Awesome. So that's baked into Prometheus and makes it really, really easy to get started and sort of build from there. But for whatever reason, if I need to, I have the ability to uninstall at any point simply by uninstalling the integration. It'll delete the alert rule namespace that we created, as well as the dashboard folder, which you can see right here, all gone. Okay, so a few resources in which to get you started now that you have a bit of an introduction. So we have a quick start actually of overall Grafana Cloud, which will lead you into a lot of our integrations, as well as a few blogs that we've written for the two newest integrations that have come out as well. So that's Kubernetes and RabbitMQ. But there's actually more, not just blogs, but other content that we're planning on creating. So we'll be super curious to see what you would like to see. Is video content or like demos more your stride, or is it more documentation, combination of both? That would be really, really great to see. So thanks everyone for taking the time to give me a few minutes of your time. So we're really excited about Grafana Cloud integrations and all the recent announcements that we have for GrafanaCon altogether. But this conversation isn't one-sided. So head on over to community.grafana.com. If you have any questions, or our public Slack actually has an integrations channel where Ryan, Gabriel, and myself, the three integrations engineers, are in there hanging out. So feel free to ask questions there. But of course, we also have our Q&A coming up here in just a minute. So stay tuned for that, and I'll be right here. Thanks again. Hey everybody, good afternoon, or wherever you are in the world, morning as well as evening, perhaps. So we have everybody here with us, Gautam, Siraj, myself, and Christian, and happy to answer some of your questions. We actually have a few ready in the pipeline. So we'll start with Alexei. Alexei asks, can the Prometheus agent customize or send data peers from the sender side? To allow the sender system to initiate the sending of metrics only on time when it is needed. I think we'll shoot that over to Christian.
So basically that is something that you can do. So the Prometheus agent comes with a config management API where you can set like the discovery config as you know it from Prometheus, with like some HTTP API. And that would allow you to customize those data periods like as you need it, kind of with cron jobs when it makes sense for you. And I think also maybe something interesting to note is that in one of the last Prometheus Dev Summits, a feature request was actually accepted to bring this bring the scrape interval into the service discovery, so you can kind of discover how often you want to scrape your targets in Prometheus once that gets actually implemented.
Awesome. Thanks for the question. So Anonymous follows up with a question about synthetic monitoring that we'll toss over to Siraj. Is synthetic monitoring available for open source Grafana or Prometheus? And also someone I think asked it in the public Slack as well, as around just the overall availability for synthetic monitoring, and is only available on Grafana Cloud.
So as of now, synthetic monitoring is available on Grafana Cloud because we use Grafana Cloud metrics and logs to store the probe data. However, you can install synthetic monitoring in your own prem and local Grafana instance and then connect those Grafana Cloud Loki and Prometheus data source to get it working. Though I would recommend you to try it out on Grafana Cloud. We have a generous free tier that would be more than enough for you to, run your synthetic monitoring checks and play around with it.
Awesome. Thanks, Siraj. Appreciate the question. So next one is, how do I get a Prometheus exporter added as an integration for Grafana Cloud or on the listings page for exporters? Listen, we're hearing a little background noise, so if everybody else could mute. So you should be able to do that sort of automatically. So the idea around Grafana Cloud is a lot of that's done for you. So maybe if we could chat afterwards, maybe dive into a little bit more of your use case. Should be able to help you out with that. Next question. Let's see. Is it hard to migrate from Thanos to Cortex? Let's see. Maybe we toss that over back to.
I can take
Gautam?
Yeah. So we have a migration guide. If you want to migrate from Thanos to Cortex, we have a migration guide for you. If you just head over to the Cortex docs into block storage, you will see migrate storage from Thanos and Prometheus. So it's not super streamless, but it's very possible and trivial to do.
Awesome. Yeah, I think you have a link to that, and then maybe we could probably toss it in Slack and even follow up afterwards. Yeah. Cool. Awesome. Let's see. Next question. Russ, give you a turn, sir. Can tenant monitoring run tests on a company's internal system via a VPN and in regions around the world?
I think it probably depends. Actually, Suraj is going to know more about this since he's more of the networking guy. So I'll kick this over to him.
Sure.
Yeah.
So you can actually run private probes inside your environments to test your internal applications. Our public probes will not be able to ping your internal applications unless you configure it correctly from your firewall side and from authentication options in the check. But if you configure things correctly, we can probe your internal applications from inside and from outside as well.
Cool. So got another question. Actually, I think we'll toss this one over to you, Christian. How do I backfill data into Prometheus? Is that possible?
So yeah, there have been some recent improvements. I think it's I think not 100% working maybe for all use cases, but basically the prompt tool that is bundled with Prometheus has some kind of subcommand where you can actually then use the open metrics format to produce you kind of the blocks that then contain your backfilled metrics. Similarly here, we will kind of post a link back via Slack.
I just want to add that I've also posted the links on Slido. So if you're on Slido, you can also click them there.
Beautiful. So Alexei asks, I saw that one of the speakers was using Firefox. Are you having problems with vertical scrolling of Grafana's panel's label tab content in Firefox by MySQL? I'm not sure who that was.
I think that was me because I put it in Firefox.
There you go.
I don't know because I haven't tried that lately, but I will give it a go. And I'd encourage you to file an issue in the Grafana GitHub repo if that's something you're seeing, because folks would love to hear about it, I'm sure.
For sure. Cool. So we got a few more minutes, and I think that's so far all of the questions. Let me just double check. Yep. So while we're here, how's everybody's GrafanaCon going so far? Pretty good?
Excellent.
Yeah.
Don't make me point. I will finger gun. No, all good. Same here. Anything in particular that you're super excited about now that Grafana 8's out?
Unified alerting.
Alerting.
Yeah. I think that's a pretty common one inside the Grafana lab walls for sure.
Yeah, and I think also the time stats panel makes really some nice kind of dashboards.
Nice for sure. Ooh, let's see. What advice do you have around retention if I'm running a lot of Prometheus instances? Whoever wants to pick that up.
Christian, do you want to go for it?
Yeah, no, I can. I guess it depends. So obviously the retention in Prometheus is a command line flag you can configure, as I'm sure you're aware. Then through things like Cortex, you would kind of remote write that into a potentially one central location, and then given you're using the block storage, you could kind of, for example, use your S3 to configure the retention depending on however you like it per tenant. Right now there's no functionality to distinguish per label or something like that, but Cortex can kind of help you with a kind of per tenant retention setting in the underlying storage bucket, for example.
Nice. Awesome. Fun question. Are you guys the three integrations musketeers? Well, I'm one of the three. Gabriel and Reiner are the other two. That I think we're hanging out in Slack. So if you want to say hello in the public integrations channel, please do so. An interesting question about tags. Can Anonymous ask, can you use tags from any cloud provider along with Prometheus and Grafana, filtering through the different resources in need of alerting. Gautam, I see you are already nodding your head there.
Yes. This is basically how Prometheus service discovery works. And we have service discovery for all the major cloud providers. So if you have tags, you can say, hey, Prometheus only monitor services with this tag, or monitor services with this tag, and add other labels to it. So all these tags can be converted to Prometheus labels, which you can use in alerts, and also to route alerts to the right teams, right channels. So all of this works really, really well and seamlessly inside Prometheus.
Nice. So Alexa asks, does Prometheus have or have plans to have a GUI for deleting specific time series of databases, not via the raw post query using curl, but via the web UI?
I don't see why not. If there's not already an open issue for it, can you open an issue for that? And once you have some consensus, just go ahead and implement it. We are rapidly improving the new UI and adding more and more features to it. And we would love to have this one too.
Awesome. A fun question from Robin. What's it like doing a Cortex talk without Tom Wilkie? Brilliant. Let's see. Any others that come to mind? Someone asked again about synthetic monitoring only being part of Grafana Cloud. You would have a free tier, but today, as of today, yes. Or no, I should say, sorry. Are there any plans, Christian asks, are there any plans to implement OIDC authentication for the Prometheus UI?
Not for the UI, but we would be implementing that for the scrapes and for remote write, but not the UI. We expect you to secure the UI again behind a proxy. There is one more question that I do want to answer, which is, are there examples of bash-based jobs rather than monitoring HTTP APIs?
Yep.
And this is something I briefly mentioned. Prometheus can now accept data via remote write. So you can actually use remote write to push data into Prometheus. We kind of don't recommend it, but that's something you can try, and that's something that's super recent. I'm trying to find docs for it. Once I find them, I'll put them on Slido.
Cool. Yep, I did. I was going to go back to that one anyway. So everybody's winning. And then last question: does Cortex support exemplars? I think you talked a little bit about that earlier.
It does. I think the PR is merged quite recently, and if you want to see it in action, tune into the talk tomorrow on Grafana tracing.
Aha, a tease. Cool. Well, thanks everybody for taking the time to ask a bunch of really awesome questions, and enjoy the rest of the con, and we'll see you on the flip side.
thank you for joining us on how we scaled out metrics here at Robinhood. Before we get started, I do have some unfortunate news though. It turns out that we have submitted our session proposal a little prematurely because this title's already out of date. Since we started working on this presentation a few months ago, we already reached a new milestone. We just hit 1 billion time series. It's been a wild ride, and I'm just here to tell you all about it alongside my co-presenter, Austin McKinley.
Hey, thanks, Dan. My name is Austin, and I'm an engineering manager at Robinhood, and currently I lead the observability team within Software Platform. I joined Robinhood about a year ago, so that means I've been fully remote this whole time, and that's worked out really well for me because it lets me spend more time here at home in Seattle with my 2 cats, Sheba and Rocky, and lets me keep working at Robinhood and keeping these cats in kibble.
And I'm Stan, a software engineer alongside Austin here on the observability team. I am also a Robinhood COVID baby, and as the pictures would suggest, my 2 favorite things in the world right now are homemade pasta and volleyball. And of course, we can't forget about the rest of the observability folks here at Robinhood, all of whom just joined us in the last few months. It's really amazing to see the observability team go from 0 to 5 engineers in a single year. But before we get started, we definitely cannot neglect to mention all the wonderful people here. Thanks so much to the Grafana Labs team, Alex, Avon, Vince, Jacob, Robert. Without you, our Cortex and Grafana agent stack wouldn't be where it is today. And can't thank you all enough for standing by us and all our late night deployments and listening to our infinite list of GitHub issues. And of course, Cortex wouldn't have a home without all the Kubernetes underneath it. So thank you to the orchestration team. And of course, Tom, our manager that stuck by us through all this. And with that, let's begin. So here at Robinhood, we're heavy Prometheus users. And as such, the structure of the talk is going to be in 3 parts that document the Prometheus dynasty as it existed at Robinhood, starting with the before Prometheus, then to the Prometheus age, and then finally, what Prometheus eventually evolved into and the future insight. So before Prometheus, disclaimer, this was before my and Austin's time, so take this with a grain of salt, as this is just the folklore as we know it. So yeah, let's talk about OpenTSDB and Raymond. This diagram shows the whole flow here. Walking through this from left to right, we'll start with the applications pushing system and application level metrics to Kafka using tcollector and statsd. Then you have OpenTSDB running on top of HBase to consume and store those metrics. We had 2 interfaces to these metrics, one with Raymond, where you write alerts, and one with Grafana, where you do dashboards and query. So we kind of experienced 2 main points, 2 main pain points in this architecture. Pain point number 1 being, a lot of moving parts. There was a fair bit of complexity involved in just getting a metric from point A to point B. Pain point number 2, in this push model also made it hard to manage back pressure. Not having direct control of the ingestion of metrics being pushed from applications and having everything go to a single Kafka topic kind of made it hard to silence noisy applications. So these were both technical pain points. And pain points that you could easily debate with us about, no doubt. But the final and most frustrating pain point was not actually a technical one, but a user experience one. And that was having different languages for alerting and querying. This made it super difficult to test alerts, as you'd always need to translate from Grafana panels and PromQL on the left here to Raymond alerts in Clojure on the right, which unsurprisingly was not very straightforward. So we wanted alerting and querying to be a frictionless process, for it to be easier to do than to not to do. So we knew we could do better. And here we have the age of Prometheus. This is when Prometheus took over. So this really helped to reduce complexity for both the operators and the users. Prometheus became a one-stop shop for scraping metrics, storing metrics, querying for metrics, and alerting on those metrics. The Prometheus ecosystem was created in a variety of ways. Had a simpler user experience with the unified alerting and querying language in PromQL. It also had a vibrant community. There was plenty of active development in the Prometheus open source project. And what that meant for us, in effect, was a GitHub issue hotline. So simplified infrastructure as well. The pull-based model allowed us a lot more flexibility with our back pressuring in the event of metric surges. So what happens is we control the sampling rate on a per application basis, which means we have very fine-grained control of our overall ingestion rate. And finally, Prometheus was pretty trivial to scale. If we needed more capacity, we could just vertically scale the thing until we couldn't anymore. So whenever querying or scraping started to slow down, we'd scale by moving Prometheus to a larger EC2 instance type. And here you can see the size of our Prometheus server, starting with an instance of 16 CPUs and 122 gigabytes in 2017, and ending with an instance of 128 virtual CPUs and almost 2 terabytes of physical memory. This was a great way to scale because it basically meant 0 engineering time or thought, and worked really well for a while. And it's worth noting that it's also possible to deploy Prometheus in a federated way to scale beyond the limits of a single physical machine. Prometheus offers this out of the box, but it wasn't practical to kind of retrain our engineering team to worry about the source of their metrics. And it was much better to have metrics kind of be available from one single place. So anyhow, with the largest AWS EC2 instance that money can buy, we seem to reach Prometheus's practical limits. But what exactly went wrong when we hit these limits, you might be asking? I'm sure you're on the edge of your seat. So here to introduce Robinhood's most viral GitHub issue is Austin.
Thanks, Dan. Yeah, so as Dan explained, starting in late 2020 or so, we started to run into seemingly insurmountable scaling issues with Prometheus, leading to problems like this one. We filed this kind of casually because it was a thing that we'd observed in production, not really expecting it to take off and get a lot of traction. But looking back on it now, this is probably one of the more interesting GitHub issues I've ever had to file. We tried to migrate Prometheus to X1 32x large EC2 instances, as Dan mentioned, with almost 2 terabytes of physical memory. And we found this really surprising behavior where Prometheus would do an crash, even though there were terabytes and terabytes of physical memory remaining. We tracked this particular issue down to an unexpected ulimit interaction. Prometheus likes to allocate lots of memory map objects to actually map metrics data into memory from disk. And a failure to create those memory map objects actually will trigger the exact same error handling, stack traces, and log messages that you would normally see from heap exhaustion. So we thought we were seeing some contrived heap situation, but it was actually just a ulimit. So we fixed this particular issue, but trying to make Prometheus run at this scale was running into an almost physical wall. No matter how we tune Prometheus or how we tune the Golang runtime, or how much disk or memory or how fast the disk and memory were that we threw at Prometheus, we could never really get it running stably in the 100 to 150 million time series range with about 1.5 million samples per second. And when you think about it, that's just totally crazy to even ask a piece of software to do that in a single binary. So this is not a knock on Prometheus. This is incredible that we were able to scale it this far. Prometheus was never designed to scale this way, and everyone that we've talked to has been blown away that such a thing was even possible. So you served us very well and nobly, Prometheus, but as they say, now your watch has ended. And that leads us to Cortex. At the same time that Stan and I, who were at the time the entirety of the observability team, that we were furiously bailing water from our Prometheus hosts, we were also in the middle of a crash migration to Cortex. We had already been evaluating Cortex as one of many potential Prometheus successors, so we weren't exactly starting from scratch, but it was still a very small team with a very tight deadline to pull off this migration because, as mentioned before, we were seeing constant issues in production with Prometheus. So among the competitors that we had available, like M3DB, Victoria Metrics, we chose Cortex primarily because it was designed to be a drop-in replacement. It's supposed to be totally API compatible with Prometheus, which was great because we could continue to leverage our large existing investment in Grafana dashboards and PromQL and alert manager configurations, et cetera, et cetera. So let's talk about Cortex. Cortex is an open source project that was started in 2019, and the first 1.0 release came in April of 2020. The easiest way to describe Cortex is that it's basically the Prometheus codebase, just sliced up into a bunch of little microservices. It actually depends on the Prometheus codebase importing it to do a lot of work. But instead of having a single monolithic binary that handles all of target discovery, metric scraping, metric storage, and query execution, Cortex puts each of those services in their own little Kubernetes component that you can scale as needed. Now, obviously, we pay a performance penalty for not having all of our metrics data literally in the exact same process's physical address space, but Cortex gave us the ability to scale horizontally, and that was more than worth the price. So I'm going to skim past the actual architecture of Cortex and the actual read and write paths that Cortex uses, but the architecture diagram is available online and the documentation is very comprehensive, explaining how the various storage engine works. One thing that you might have noticed was missing from the previous diagram is that actually scraping the metrics so they can be written to Cortex. Cortex, like I said, is just a time series database engine and query engine. So unlike Prometheus, we actually had to set up some additional infrastructure to get data out of our infrastructure and into Cortex. So our first attempt at this did not go so well. We tried to reuse our existing crippled Prometheus host to do a remote write to Cortex, while stopping all queries from hitting Prometheus and dropping the Prometheus retention period to less than a day. Unfortunately, no matter what we did, a single host was still unable to keep up with our sample rate, even with 2 terabytes of memory and hundreds of virtual CPUs. So fortunately, Grafana Labs has a solution to this issue. Grafana Agent is another open source project with one single job. It scrapes metrics and writes them into Cortex. It only does remote writes, target discovery, and metric scraping. I like to think of it that it's like Prometheus with the back half ripped out. It does target discovery, scraping, remote write, and that's it. It doesn't write anything to disk. It doesn't have any query engine, and it ends up with significantly better memory and resource usage characteristics than the unmodified Prometheus binary. Unfortunately, even with that new resource optimized Grafana agent, a single physical EC2 host could not keep up with our write rate, even again with those same resources that we discussed earlier. So we sort of improvised a kind of hackish way to distribute the scraping workload. To the extent that there's one weird trick in this talk about how we scaled our infrastructure that's not obvious from Googling around, this was it, doing distributed metric scraping with this hash mod operation. The little known hash mod relabeling rule exists in the Prometheus code base. And this relabeling operation lets you do the seemingly pointless operation of hashing an arbitrary Prometheus source label and then writing it to an arbitrary target label. The trick here, it comes in this second relabeling rule. And that second rule, as you can see, is only going to keep metrics where the resulting hash matches the shard ID of the particular Grafana agent whose config is being looked at here. So the real nice benefit is that because we're applying this hashing and relabeling to the scrape target's IP address, we can do this relabeling after service discovery, but before metric scraping. So we aren't actually scraping every metric and then discarding the vast majority of them. We're only scraping the metrics we're actually going to write. So this was a huge success. And with a very small amount of time, we were able to successfully scale up our Grafana agent and Cortex deployment to handle all of our prod traffic without running into any of the scaling issues we were seeing with Prometheus. After a few months, however, we decided to migrate to Grafana Enterprise Metrics to get access to some of the newer paid enterprise features like SSO auth, but most importantly, a solution to one of the biggest issues we ran into with Cortex. So the biggest problem we've had with Cortex is the number of blocks created and distributed by Cortex. These data blocks are created all the time by Cortex's ingesters, and under normal operations, they get almost immediately compacted into 2, 12, and then 24-hour blocks by a Cortex component called the compactor. The stock Cortex compactor expects that most of your metrics will be more or less evenly distributed between multiple Cortex tenants. And the only parallelism you can get is by running concurrent compactions on multiple tenants. Unfortunately, when we initially deployed Cortex, we created a single large tenant to store all metrics. This basically matched up with the existing engineering expectations that all metrics would be in one place, and you would never have to worry about where your queries were running. The whole universe would always be available. But for us, this number of blocks being created became a huge bottleneck. Fortunately, one of the key features of GEM is the vertically scalable compactor that let us make a whole lot of progress and break through our overloaded number of blocks. This scalable compactor lets us throw a lot more hardware resources at the problem of compaction, but unfortunately, it still doesn't let us scale the compactor beyond a single physical host. So that means that the one lesson you can take away from this is that if you're going to run a metrics cluster in Cortex at our scale, you should definitely plan on creating tenants ahead of time. Don't throw everything into one bucket and then try and work on it after the fact. Currently, migrating to a multiple tenant Cortex configuration is one of the highest priorities of the observability team. So that takes us to today. Today, Cortex and Grafana Enterprise Metrics at Robinhood is handling about 10 million samples per second. That's about 2.5 gigabytes per second of metrics write traffic hitting the load balancers that front Cortex. That's about 1 billion simultaneously active time series. And we're running this on a cluster of Kubernetes resources with combined about 15,000 CPU cores and 30 terabytes of memory. All of this is backed by a 200 terabyte S3 bucket that we use for long-term storage and persistence. And this whole infrastructure runs with a 60-day retention time, and we're sampling at 15 seconds across the board. We're actually not doing any rollups right now. That's a feature that's coming down the road in Cortex, but we'd like to store even much longer data at a lower resolution. And of course, this wouldn't be GrafanaCon without mentioning the actual Grafana visualization component itself. Robinhood is very invested in our Grafana install. We use Grafana across engineering to view internal system metrics and track the health of our various services. We have more than 1,000 dashboards. We have thousands and thousands of alerts crafted by individual teams to keep track of their infrastructure. And we have multiple integrations, not just with Cortex, but with other data sources like CloudWatch, Jaeger, et cetera. So also, obviously, the Robinhood observability team is not going to rest on its laurels. We have a lot of goals, both for capacity-wise of reaching 2 billion simultaneously active time series and adding new features as well. So as I mentioned, our highest priority right now is migrating to a multi-tenant configuration so we can do much better and more granular rate limiting and fault isolation between components at Robinhood. We also want to enable automatic tenant provisioning so that new teams and new services can get spun up with observability infrastructure all on their own without having any humans in the loop. We're also exploring an active-active deployment for Cortex. Right now, we kind of depend on a single Kubernetes cluster and a single Amazon availability zone. So we'd like to actually spread that disaster reliability risk around more because the Cortex infrastructure is absolutely critical for administering the site. And that's just mentioning the metric side of observability. None of this has had anything to do with logs and tracing, the other two pillars of the observability team at Robinhood. The team is very small and we're growing very rapidly, and we'd love to have you come join us. So thank you. If that sounds really interesting, Robinhood is hiring. There's a link to our careers page here. We'd love to have you. Thank you very much for coming, everyone.
Everybody, my name is Adam Mills. I'm here to talk to you a little bit about how you can use Prometheus and Grafana to create useful dashboards for yourself and also for your customers. So just a little bit about myself before I get started. As I mentioned, my name is Adam Mills. I'm a principal traffic engineer at Roblox. I've been doing online infrastructure for over 8 years. I built data centers and POPs in various countries and locations. I'm extremely passionate about low latency gaming for players for obvious reasons. My son is an avid Roblox player, and I want to make sure he has a great experience every time he logs in. So what does a traffic engineer do at Roblox? Our main responsibility is working with load balancers and ingressing player traffic through our various POPs by terminating TCP and TLS as close to them as possible using technologies like DNS. But as a load balancing engineer within the data center fabric, I frequently get asked questions that I don't specifically have an answer for at the ready, which requires me to log into a device, validate configurations, and make sure that customers have a good feeling when they leave an interaction with the load balancing team. Some of those questions might be, do I have sticky IP enabled on my service? What algorithm is are the load balancers using to reach my service? Are the load balancers all configured the same? Because there might be a disparate number of connections going to one server versus another server. And then where is the load balancer for my service? Sometimes it feels like there's a black box, a hidden thing in the middle of the infrastructure that one service needs to talk to another service, and it's going through some mystical magician. And what I set out to do is I wanted to alleviate any of those questions and make all of the answers immediately available for customers to consume. And I thought that maybe doing it in Prometheus and displaying a dashboard might be a really cool way to do that. So we have Node Exporter running on all of our servers at Roblox, which, if you don't know, it's a Prometheus style exporter that gathers data from the local Linux system and presents it in Prometheus. What not a lot of people know is that it actually has the ability to ingest files that are configured with Prometheus information in them, and it will display them as if they were metrics coming off of the boxes themselves. And so I figured that taking advantage of this system would be a really neat way to get that information displayed. It can be any arbitrary metric information, and I'm going to show you some of the examples of metrics that I invented to help display this information for customers. We use Ansible to manage these files, so we generate the files and store them in the Ansible directory or in the Node Exporter directory. Ansible renders them from a Jinja template and puts it on there every time a config update is made. And then we make it accessible because it's coming up through the Prometheus or the Node Exporter endpoint in the Prometheus format. We scrape that same metric as it is everywhere, and that data is easily consumable on the Prometheus endpoint. You can have n different metrics in n different files. So you can fill this directory up with as much as possible. Do keep in mind, that IOPS on system, et cetera, you don't want to overload it. But it is a very interesting and cool way to get that workload done. And then, of course, you just have to follow the Prometheus formatting rules when you're making your custom generic metrics. So here's an example of a metric that we invented to display components. So a component at Roblox is almost like a microservice, but it's deployed on a bare metal system. So you might see 3, 5, 10 servers in a particular component, and it serves a specific purpose. In this particular example that I did, we have a service at Roblox called Users Add Service. And if you can see based on the labels that are being created, it's using the least cons algorithm. It does use sticky IP. We throw in the domain there, which I'll tie it back in later on, but that's really cool metric to have, or a label on metric to have, to be able to parse through and see other useful information based on that particular metric. It is configured on the private side of our network, and we communicate from load balancer to the service across HTTP. So it kind of lowers the load. I put in there a value of 1. It doesn't really matter. All I really care about are the labels, and I'll show you why. So in Prometheus, we're displaying that data using the Node Exporter, but then we're graphing it in Grafana. And as you can see, we're using that component label. We're searching through and finding those interesting labels for component, instance, and host header. And then we're displaying that information. Is it sticky? In this case, it's not sticky. It's using least cons. And then, of course, which load balancing cluster is it on? We have that value displayed there for the customers, and they can easily digest this through the dashboard. And in most cases, when people come to me now, when they have questions, hey, what is the configuration of my load balancer? I generally just send them the link to Grafana, populated with their user service. I don't give them the answer. I let them find the answer on their own, because then they're going to be more likely to hit that dashboard the next time they have the same question. So now that I've showed you one cool example of what we can throw in the lake, what else can we do with Prometheus and Grafana to make our workload, or the questions, the frequently asked questions that we have, more accessible for customers and potentially even executives? At Roblox, we use this idea of what's called a design revision. So we have various workloads within the data center, specifically around load balancing. As I mentioned, some of them are configured for private services. We also have public load balancers. We have load balancers running at our edge. Each of those workloads are very distinct and require a different set of environment variables to configure them. So at Roblox, a design revision just defines the purpose of that particular instance of load balancing. But moreover, it's a generic way to logically group environment variables to allow the load balancer to be self-configured, but we also need to be able to display that data so that everybody can consume it. We also do container revisions. That's an interesting bit of data that we might want to have accessible easily for customers and for ourselves to consume. Which container is an interesting, as we revise, as there's new instances or as we change versions of code within the container itself, keeping track of that's a really useful data point. Also, if you run bare metal services, you know that there is the potential of outage of a particular rack or a pod, which is at Roblox, it's a grouping of racks, or even potentially a whole data center. So being able to graph that information of where are my load balancers within the infrastructure can actually you can glean some very interesting information from that as well. We also track the migration status. So as we move services between different load balancing clusters, we can actually display that data in a Prometheus format and then graph it as well. And I'll show you how we do that. Checksums. If you're running any system that has an IP whitelist or blacklist, this is a very interesting data point to have, where you can run a checksum against the list of IPs that are in the whitelist or blacklist. And you can prefer those, and you can check that checksum across all of your hosts in a very easily manageable format. So here's all that data, but why do we have it? Well, in this particular case, I was doing an upgrade. I was moving between design revisions for the RBLX 01910. And look, there's 5 of them that are running an older version. It made it really easy for me to be able to identify which servers those were that needed to be upgraded and which ones weren't, which ones had already received the new upgrade. And also, as you can see, we have a really nice graph of how are things broken down when it comes to design revision, and also our GitHub load balancing, the software, that layer 4 software that we run in front of our HA proxy instances. We have different design revisions for them, because again, each one of those design revisions is a different workload at Roblox. And so I can see the breakdown. It's very, very nice and very pretty. I usually monitor this when I'm curious about an upgrade or curious about the status of things. Also, because we have that pod and rack design, I can also break it down by pod and see that in pod 7, we have the distribution of servers and services within there. As you can see, our GitHub, our GLBs are evenly distributed within that rack or in that pod. And they're all running the same design revision the Docker image, and we have variants on design revision. But it's really useful and great information that'll allow us to identify issues or identify places where you need to pay more attention. So what are some other of life's questions that you might be able to present to users using Grafana and Prometheus? We use a technology at NS1 called shed load. Basically what it is that we provide NS1, which is a DNS provider, the capacity of a particular POP. We use load average of the HA proxy instances at the POP to tell them how much more or less capacity we can run at a POP. The question always is that I set that value 6, 8, 12 months ago. what is that value? Is it still doing what it's supposed to be doing? Without logging into their dashboard of these third-party dashboards, can I get that information ingestible and displayed? Also, people might have the question outside of our particular group that has access to this third-party system. Without having to grant them access to that third-party system, can I gather that data and present that to them to show them what those values are without potentially compromising security? So with the show lead feature, every 2 minutes, I'm pulling not only our stats, but what stat is configured on the NS1 dashboard for that same value. And we also pull the high watermark and the low watermark, which is basically the low watermark is where, hey, I need to start shedding load away from this pop. And the high watermark is, we're over capacity and things, please drain the site. So we gather all that information, the high and low and watermarks, and this is a distribution of load across all of our pops during this given time frame. So you can see how it ebbs and flows across the different data centers, but none of the data centers reach that excessive CPU, and everything is the system is able to operate independently of us. But we also have that data available for technicians and engineers on our side to be able to view that data without having to log into NS1's dashboard. And this is a more broken down thing of one particular site, Atlanta, where it shows the high and low watermarks, and you can see that the two lines for on our side, what we view as being the Prometheus load, and also the load that's configured there, to see if there's any discrepancies on what we're sending them versus what we believe to be true. So how is the load balancer migration going? It's another question that we get asked frequently. So every 5 minutes, I have a little script that all it does is ping all of the internal services, and it gets the IP address back of what that service is, and it displays on it. I know which data centers and which IP addresses should be responding for those instances. And so I can graph that information and get that data accessible without it's basically taking the tribal knowledge from my brain and presenting it into a graph for a customer. And it compares those lists to different IPs. And as you can see, as we're doing the migration away from our instances, you can see the breakdown of which components have been migrated and which ones still need to be migrated. And luckily, we actually had this information displayed. Recently, we had an internal site issue where we were actually presenting the wrong IP to internal clients. And it was actually, we caught it because of the dashboard that we had. It didn't cause any serious issue to players. They were still able to start and play games, but some of our internal systems were having timeout issues because they were getting the wrong IP and they were terminating at a place they weren't supposed to be going to. But we were able to graph it, and now we actually have an alert for that particular issue so that the next time we can easily identify and correct the issue before it becomes too serious. So this is the IP whitelist and blacklist question. So we have a couple of instances where we need to be able to whitelist and blacklist customers or particular subnets within our external facing load balancing algorithms. And so what we do is we gather all that information, all of those IPs, we whitelist the ones that we need to whitelist, and we blacklist the ones we need to blacklist. We create a checksum, and that checksum then becomes the label, and then we can compare that label across all of the different instances of the running service to make sure that all of those have the same whitelist. So when security asks us, hey, is the whitelist the same? We have an immediate answer that yes, we don't have to log in and verify. We already know. We also use NS1's Pulsar technology, which basically takes samplings from all of our customers and then targets them to specific pops. In this particular case, the pop in question, we wanted to make sure that as we make those changes in NS1's Pulsar, hey, start steering this traffic away, is the answer that they're getting the best potential answer, the lowest possible latency? And we're actually graphing that information and displaying it. And so, as you can see, the gold, it's the best answer, and that's the one that we want to serve to customers. The other two answers, the response times are significantly slower and can cause page load issues. So we use the gold one to validate, hey, are we doing the best thing for our customers? And in the United States, it's clear that that answer is true. And sometimes that bit of information, all of the DNS queries and all of the design revisions, that doesn't give a good roll-up idea of what it is your particular department does for your company. It sometimes doesn't display the amount of impact that you have. Sometimes you have to create that dashboard to actually show executives and show people in senior leadership what it is that your team actually does. And sometimes that can be through just rolling up some of the dashboards into some high-level information. Maybe you take one of those really important metrics and you display it proudly for what you guys do. So when people ask the question, what is it that the traffic team does? We turn the red dots into green dots. So thank you everybody at Grafana for having me and hosting me. Thank you all for listening. And I hope you guys have a great day. And I hope you can take some of this information and create meaningful, useful dashboards for you, for your team, and to show off and highlight the impact that you have at your company.
Apparently I was on audio, so here we go. We'll try this again. Hey everybody, thanks for tuning in. I'm Adam. That was a little embarrassing. You got so many mutes, you don't know which mute is the right mute. So I'm here to answer a couple of questions posted. Thank you guys so much for watching. I hope you guys are having a great time at GrafanaCONline. The number one question that I have is that how close are the dashboards when my kids are playing Roblox? Frankly, I think my kids are actually better at detecting anomalies at Roblox than we are. They're frequently coming down here to tell me things are different. Usually there's not an issue. They just, a game developer came up with something new, or something's not to what they're used to. But they're pretty good knock technicians. Hopefully they can grow up and find a good job. That was another question that frequently came up during the broadcast, was about careers or internships. Roblox, we're currently in the summer, so we've already filled all the slots for interns. But if you're curious about working at Roblox, you can go to our careers.roblox.com. That'll take you to a page where it displays all of our open and available job openings. And if you are underage, if you have friends that are interested in working at Roblox, I think the number one thing that they could do is that Roblox is a platform for learning and education. So if they go online to YouTube and find interesting ways. So Roblox, the player, is where you find all the content that's already been created. Roblox Studio is where we encourage kids, young adults to go and make games on their own and publish them on our platform. So we're not a game company, we're a platform company. And so we want to attract that younger age kids to be interested in making video games, interesting in publishing content. And people, it's a community driven platform. So all the content that you find there is for your use. You can create games. My son is frequently making games that just he plays on. He doesn't actually publish any of them, but he likes to recreate his favorite scenes in movies in a game, and then have us come and take a look over his shoulder. So the question was how is adoption for Grafana? When I started 4 years ago, we had a pretty intense display setting where it was just the common place where everybody put their graphs for their metrics. Personally, I think that metrics is great, but if you can't display how important they are or what value they provide, it's just numbers in a spreadsheet. I mean, nobody, it's when you take that data and make it mean something is where the importance happens. And so we've been trying to use the fundamental that was built 4 years ago and porting that over, because the extensibility on Grafana is immense. You probably have heard about their recent partnership with things like Elasticsearch to provide those types of values so that you can see all of your data points, whether it's Prometheus or a homegrown metric, influx, Elasticsearch, we're doing a really good, pretty good partnership with them to try to get as much of our metrics displayed and available through their dashboard. So a lot of teams, I guess, is the answer. The question is, does your dashboards or alerts for networking issues correlated per service? A lot of that stuff is done on the actual Prometheus side. So we will create an alert for a service and we'll do the correlation there, because the extensibility, and I mean, I apologize to all the Grafana people, but the alerting through Grafana is not top tier. It's not top shelf. I don't think that was their initial intention. They kind of extended it to use it, and some of the functionality isn't always there. But we use a lot of Prometheus to do that correlation information before it comes to the Grafana displaying of it. But having as many of those, and you don't want to use an infinite number of labels, but having those labels, I didn't mention as much, but like being able to take the domain name and correlate it to another graph is huge. You know, like you can take the domain name and you can look at how many 500 errors or 400 errors or 200s are being displayed. And then you have that information of like, when did things change? Oh, you changed it to sticky and 500s went up. Like that's all stuff that you can do in Grafana, and it's pretty cool. Things that are how are you using any load balancing resiliency for your Grafana servers? So one of the fundamental things that I try to instill is that you should never use the thing to monitor the thing with the thing they use to use the thing. And I know that sounds confusing, but basically, yes, we do have a load balancing infrastructure in front, but that's not the same load balancing infrastructure that we're using or monitoring that I was displaying here. And the reason being that if the stuff that we're working on goes down and you have no access to view that it went down, you're kind of sunk. So we do have a partnership with Nomad, with the HashiCorp team, and so we display a lot of that stuff is being put into Nomad. So Grafana and its database is being put there in Docker containers, and then it's being we have some other internal load balancing technologies that we use, that stuff that wasn't related to this, but that's how we do that. Some stuff that's happened since I recorded this a couple weeks ago to today. It actually challenged me to think about new ways to get that data that I was referencing in the Nomad exporter. So we have a huge scrape that happens from Node exporter, and then HA Proxy, which is our reverse proxy technology, has a completely different Prometheus agent, because there's just so much data that goes through into Prometheus. I was challenged to figure out how can we get some of that Node exporter data into the HA Proxy scrape without having to do some sort of weird group lefts on data that may or may not exist. And so the interesting thing that I came up with was that in HA Proxy, they have this idea that you have a stats page. And before it was just generic, we just called it stats. That was what the front end was called. But what I ended up doing was I took that front end and I converted it to display the design revision, like that's the literal name, design revision. And then I put a period so that I can do some regex on that. And I put in there the rack, and I put in there the pod, and I put in there the container revision. So anyway, some really interesting things of how can you fit the data into Prometheus so that you can then, when it's up in Grafana, you can parse it and look through it and do that interesting correlation. So anyway, that was just interesting stuff that I've been working on since the talk, but I appreciate everybody's questions. Thank you so much for attending, and I hope you guys have a great GrafanaCon.